Some unique problems arise when multiple threads are running. You can see where two threads could be changing and reading the same group of data items and get themselves confused. In such a multitasking system, any thread can interrupt any other thread at any point. It's a similar problem to multiple programs accessing the same database. Now, this is solved in Java by having one thread assume temporary ownership. The ownership can be of an entire method or of a block of code inside a method. Here is an example program that shows what happens. The class extends Java lang thread so it can be run as a thread. The main loop of the class creates 100 objects and each one is started as a thread. The run method just calls the show value method and then returns, so that's all that each thread does. Now here is the method that's executed. The static variable named value is incremented by 1, its value is then printed, and the value is put back the way it started. The value is static, so it's stored in the class, and the same variable is used by all these threads. The value begins at 0, so if no two threads come through here at the same time, the only value ever displayed should be the number 1. Here's what happens. As you can see, the value gets a bit larger than 1. That means that more than one thread is inside the method at the same time, but you can force only one at a time this way. This is the same program in every way but one. This method is declared as synchronized, so only one thread at a time will come through here. Each thread has to wait until the one before it has finished with the method call before it starts. So the value is always put back to 0 before another thread adds it back up to 1. Now, one important note here. Let me show you the source again. Notice that the show value method is declared as static. That means the method exists as part of the class, not part of each of the objects. That way, all the threads share the exact same method. If the method were not declared as static, each thread would have its own method, and even declaring it as synchronized wouldn't help. Each thread would have its own method to execute independently. The point is that synchronizing a method only works if the two threads are calling exactly the same instance of that method. There is another way to synchronize statements. You can synchronize a block of code instead of synchronizing an entire method. All you need is common access to the reference of an object. That is, all threads need to have access to the same object, and you can use it for locking. In this example, a lock object is created. It is a static reference, so all objects of this class will address the same reference by using this name. Now here is the start of the synchronized code. You could have other code in this method that comes before this synchronized block, and you could have other code in the method that comes after the synchronized block. It is only the code inside the block that is synchronized by the object. And notice that this method does not need to be static. It's the string object that the lock is hung on, not on the method. It works the same way as the previous synchronized example. Each thread, when it comes to the synchronized block of code, waits for the thread before it to complete before it continues.